Le B-2 Spirit reste le bombardier furtif le plus redouté de la planète. Icône de l'armée américaine, cet appareil voit le jour durant la guerre froide. Mais ce véritable bijou de la technologie a un coût astronomique, ce qui freine quelque peu son ascension dans l'industrie militaire. Néanmoins, il est un fidèle soldat pour les États-Unis, notamment grâce à la montée en puissance de la furtivité. À l'heure actuelle, la légende de l'air est-elle en passe de prendre l'eau ? Quoi qu'il en soit, l'armée américaine ne fait jamais les choses au hasard. Face à la perte de vitesse du B-2 Spirit, elle mise sur le B-21 Raider. Ce dernier devrait renforcer la position mondiale du pays. C'est notamment pour cela que le Pentagone vient d'autoriser la production de ce nouvel engin. Mais que savons-nous exactement sur le bombardier furtif le plus célèbre au monde ? C'est ce que nous allons...
This is the Horten HO-229 jet fighter bomber. It was intended to be one of Germany's super weapons in an attempt to turn the tide of the war with a fighter bomber that could reach a speed of 620 miles an hour. With its futuristic appearance and wooden framework, the Horten was unlike any other plane from World War II. But was it a real technological breakthrough for its time, and was it stealth? We've modelled the Horten in minute detail, inside and out, to try and answer these questions. The Horten HO-229 was developed in the late stages of World War II and was the first flying wing aircraft powered by jet engines. There were two flying prototypes built. In this video, we'll focus on the V3 prototype that was captured by the US Army in April 1945 and researched afterwards. My name is David Webb, and this is Blue Paw Print. Despite its futuristic shape, the airframe was quite rudimentary and extensively used wood in its construction. The aircraft was 9 feet 2 inches tall and 24 feet 6 inches long. The aircraft's wingspan was 55 feet 1 inch, and the wing area was an incredible 557 square feet. The formidable flying wing design was intended to increase speed and significantly reduce drag. The fuselage was built from steel and wood, and the two engines that powered the Horten HO-229 V3 were incorporated into the plane's main body. The skin covering the steel airframe was made from plywood, which formed the recognizable aerodynamic shape of the jet. The aircraft's empty weight was just over 11,000 pounds, and its maximum weight was just under 20,000 pounds, which is about the same as a modern F-16, albeit without any weapons or fuel. The fuselage, wings and landing gear were all built into a unified design. The aircraft's plywood skin varied in thickness to obtain an aerodynamic shape. The plywood was made of layers of thin veneer of European beech glued together, which formed a strong and lightweight design. It also had the advantage of using readily available materials. The plywood was attached to the metal airframe via wooden spacers. Since the Horten HO-229 V3 was mainly made of wood, it could swiftly catch on fire if sparks were present. This is why the plywood skin was painted with a fire-repellent green paint. The HO-229 was one of the first planes to use the flying wing concept, where the fuselage and wings formed a single structure. Why did the Germans choose this design, and what were its advantages? In short, it gave a greater lift and reduced drag and gave better maneuverability. The plane's flying wing design was made from two delta-shaped dihedral wings angled upwards at 4 degrees relative to the aircraft's horizontal axis. The dihedral wings gave the advantage of better aircraft stability during rolls. A secondary spar provided attachment points for the ailerons, a control surface specific to the flying wing design. The exterior of the wings was made of plywood boards. The almost tailless design of the aircraft did not include a vertical stabilizer, which increased the chances of side-slipping and potentially flat spins. flying wing design without a vertical stabilizer wasn't used for over 50 years after the war in an operational aircraft. In part, this was due to the number and complexity of control surfaces that were needed to keep the plane stable. Ailerons were positioned on the trailing edge towards the wingtips. They were used to control both pitch and roll, instead of the more traditional setup of ailerons and an elevator. When both ailerons were in an upward position, the nose would pitch up, and when both ailerons were in a downward position, the nose would pitch down. When the aileron on the right wing was up and the left was down, the plane would roll to the right, and vice versa. Each wing of the Horten had 2 flaps on the trailing edge. These flaps were used during takeoff and landing, and in other situations, whenever the pilot needed to increase drag. Spoilers were another essential feature on the Horten. These were placed near the wingtips to create more drag and decrease lift. A lifted spoiler disrupted the airflow above and below the aircraft, increasing the drag. Other spoilers were placed underneath the plane to the rear. Spoilers were critical in maintaining stability during landing and also at high speeds. Next to the spoiler on the wing was a drag rudder. Drag rudders operated in pairs on the wing's upper and lower surfaces. When a drag rudder on one wing was used, it acted as a surface for yaw axis control. When the drag rudders weren't being used, they were laid flat. With spoilers and drag rudders activated at the same time on both wings, drag was significantly increased. While ahead of its time, the many control surfaces and lack of computer control made the plane exceptionally difficult to fly, a problem that wouldn't be solved for many years after the war had ended. The Horten was powered by 2 Junkers 004B2 Jumo engines, each with a thrust of 8.5 kilonewtons, or 2,000 pound force at 8,700 RPM. The engine's length was 12 feet 8 inches, with a diameter of 2 feet 8 inches. The engine weight was 1,585 pounds. Air was drawn into the open front section, then compressed by an 8-stage axial compressor and fed into one of 6 combustion chambers. In these chambers, the compressed air mixed with the injected fuel, and when ignited, it created a hot gas stream. 2 engines could propel the plane to a speed of 607 miles an hour. This came close to hitting the Luftwaffe's design target of 620 miles an hour. But the aircraft's rapid pace came with a price. The engines were exceptionally fuel-hungry. The high-speed performance of the engines led the turbine to be prone to overheating. By the end of the war, Germany couldn't source high-quality alloys. This forced them to utilize lower-quality steel in the engine turbines, reducing the engine's service life to approximately 20 hours of usage. The intake cowlings were made of metal panels and hammered to fit over the plywood material on the leading edge of the jet. The exhaust panels were made from flat steel parts with a concave area. Metal panels protected the wooden structure of the plane. The fuel system consisted of 8 aluminum tanks, 4 on each wing. 2 smaller tanks were positioned on the wing's leading edge, and 2 more prominent ones on the central part of the wing. Their total capacity was nearly 528 gallons, and fuel consumption was around 343 gallons per hour. The fuel primarily used in the Junkers 004B engine was J2. This was a German World War II synthetic fuel made from brown coal. It was pumped using the electric pump positioned next to the wing roots and the fuel tanks. The plane was designed to be armed with either 2 Mk103 or Mk108s. Both were 30mm caliber cannons and manufactured by Rheinmetall Borsig. The Mk103 had a rate of fire of 380 rounds of high explosive projectiles and 420 armor-piercing rounds per minute. The Mk108 packed a significant punch and was most likely to have been used against bombers. Unfortunately, we don't have any precise information on how much ammunition could have been stored. But when compared to a similar system on the Me-262, it was most likely to have been around 200 rounds for 2 cannons, in which case the ammunition would have been fed to the guns from a belt. Also, the Horten was designed to take 2 1,100-pound bombs, albeit at the cost of increasing its overall weight, leading to changes in drag and required power. Even though armament was in the design, the prototype that was captured and inspected by the Americans was unarmed, possibly because of war shortages or because it was in an incomplete stage of construction. The Horten was a single-seat aircraft. The canopy was of a curved design, and the canopy's curvature significantly increased the pilot's visibility, and without vertical stabilizers, gave the pilot a clear view of the rear of the plane. The canopy consisted of 2 parts, with the windscreen at the front and a rear section which slid back in order for the pilot to gain access. Directly in front of the pilot was a main panel, upon which were switches for ignition, indicators for vertical speed, turn and bank indicators, airspeed indicator, and fuel warning lights. The second row of the panel housed indicators showing the flap's position, an altimeter, a compass, and 2 fuel indicators, one for the fuel tanks on the left wing and one for the fuel tanks on the right. There was also a direction finder indicator, which was an advanced piece of navigation equipment for the time, which picked up the direction of a radio beacon. Additionally, there were indicators for ambient temperature, engine RPM, and oxygen indicators showing pressure and flow. On each side of the control panel were 2 gauges for fuel injection pressure and exhaust temperature for each of the 2 engines.